Hi everyone, myself is Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Okay, today I want to discuss about the topic on definitions of matrices. What is matrix? A system of mn numbers, real or complex, arranged in the form of an order set of m rows, each row consisting of an order set n numbers between the brackets, open brackets, square brackets are known is called a matrix of order m by n. Okay, this is the example for that. Here we have to consist m rows and n columns. Write it as m by n. Here m is I values in between 1 to m and j values in between 1 to n. Okay, and here some types of matrices are there in that. Okay, once before going through the types of matrices, how to define the matrix, or how to define with the matrix with as the capital letter A. Okay, some types of matrices. A square matrix A of order n by n. Okay, that means simply square matrix means rows is equal to columns. Rows is equal to columns. Then it is called as a square matrix. Here the given matrix, this is 2 by 2. This is 2 by 2 matrix. Here rows and columns are equal. Similarly, rectangular matrix. Rectangular matrix means rows not equal to columns. Rows not equal to columns. Once observe, there are 2 rows and 3 columns. Next, row matrix. A matrix of order 1 by m. That means row matrix consisting of only one row. One row. And column matrix means a matrix consists of only one column. And unit matrix. What is unit? What is unit? A is equal to Aij such that Aij is equal to 1 for I is equal to j and Aij is equal to 0. That means except diagonal elements remaining all are zeros. Here in the diagonal elements are all equal to 1. The type of matrix is called as unit matrix. Next, zero matrix. A zero matrix means if A is equal to Aij such that Aij is equal to 0, then A is called zero matrix or null matrix. That means here all the elements are equal to zeros. All the elements are equal to zeros. Next, diagonal elements in a matrix. A is equal to Aij, the elements Aij of A for which I is equal to j. Okay, are called the diagonal elements of a matrix. In the given matrix, what are the diagonal elements? 1, 5, 9 are the diagonal elements are 1, 5, 1, 5, 9. Note, the line along with the diagonal elements like is called the principal diagonal of A. Diagonal matrix. A square matrix, all of whose elements except those in leading diagonals are 0 is called as diagonal matrix. A square matrix whose diagonal elements are 0 is called as a diagonal elements. It is written as A is equal to diagonal of D1, D2 and Dn. Okay, for that example, A is equal to diagonal of 3, 1, minus 2. For that here this is 3, 1, minus 2. Scalar. Once observe, except diagonals, remaining all are zeros. Scalar matrix means it is very simple, same as okay unit matrix. Here but the diagonal elements are equal to all are equal. That means either 2 or 3 or whatever it is that, but diagonal elements are equal. For that except diagonal, remaining all are zeros. That type of matrix is called as a scalar matrix. Equal matrix. Two matrices Aij and Bij are said to be equal if and only if A and B are of the same type. Okay, second condition, Aij equal to Bij for every I and J. Next, third one, the transpose of a matrix. The matrix obtained from any given matrix A by interchanging its rows and columns is called the transpose of A, and it is denoted by A dash. Okay, for any matrix we have to interchange rows as columns or columns as rows is called as a transpose of a matrix. It is denoted by A dash. Next, conjugate of a matrix. The matrix obtained from any given matrix A on replacing its elements by corresponding conjugate complex number is called as conjugate of A, and it is denoted by A bar. That means here Conjugate means only you have to take the conjugate of the complex numbers. Here once observe the example 2, 3i, 2 minus 5i, minus I 0, 4i plus 3. This is 2 by 3 matrix for the conjugate. How to define that conjugate? A bar. For that there is no changes in the real numbers, only the changes for the complex. That is 2 minus 3i, 2 minus 5 as 2 plus 5i, I as minus I as I, 0 as 0, minus 4i plus 3. This is the conjugate. Here the properties for that: a bar whole bar is equal to a plus b bar is equal to a bar plus b bar, a bar is equal to k bar into a bar, and ab bar is equal to a bar b bar. AB bar is equal to B bar. Next, upper triangular matrix. Upper triangular means a square matrix all of whose elements below the diagonals, leading diagonals are 0 is called as upper triangular matrix. Once observe this upper triangular, here the below the diagonals are equal to 0. This is called as upper triangular. Similarly, what about the lower triangular? Above the diagonals are 0. Here, what about the above the diagonals are 4 to 6? That above the diagonals are 0, 0, 0. This is lower triangular matrix. And a triangular matrix. A matrix is said to be triangular matrix. It is either an upper triangular matrix or lower triangular matrix is called, that is triangular. Symmetric matrix. A square matrix A is said to be symmetric. Whatever is the condition for that? A transpose is equal to A. For that example, AHG, HPF, GFC. A transpose is equal to A. What is A transpose? You have to interchange the rows and columns. Next, skew symmetric. A square matrix A is equal to Aij is said to be skew symmetric if Aij is equal to every Ij. Here the property for the skew symmetric, A transpose is equal to minus A or A dash is equal to minus A. Okay, for that example 0A minus B minus A 0C, B minus C 0 is a skew symmetric matrix. Here, important point for the skew symmetric, here every diagonal element is definitely is 0, necessarily 0. For that case only the given matrix is skew symmetric matrix. What is the difference between symmetric and skew symmetric? Symmetric means A transpose is equal to A. Skew symmetric is A transpose is equal to minus A. Okay, next, sum of the matrices. Let A be a matrix. Let A, B are the two matrices. The matrix C is equal to Cij, where M by N. That is, where Cij equal to add the two matrices, that is A and B, that is Aij plus Bij, is called as sum of the matrices of A and B. The sum of A and B is denoted by A plus B. Next, the differences of matrices. Difference means what? Negative. Subtracting one matrix to the other matrix, that is A minus B. Matrix multiplication. Let A is equal to Aij, let B is equal to Bkj. Then this matrix C is Cij, where Cij is called the product of the matrices of A and B in that order, and we write it as C is equal to AB. The matrix A is called the prefactor and B is called the postfactor. Note, if the number of columns of A is equal to the number of rows in B, then the matrix are said to be conformable for multiplication in that order. Okay, matrix multiplication says we have to multiply two matrices. Okay, after multiplying we get one matrix, that is we have to assume with the C. Okay, positive integral powers of a square matrix. Let A be a square matrix, then A square is defined as A into A. Now, by associative law, A cube is equal to A square into A. Similarly, we have A power m minus 1 into A is equal to A into A power m minus 1 is equal to A power m. Where m is a positive integer, then A power n is equal to 0 and 0 power n is equal to 0. Trace of a matrix. What is trace? Trace means there. Okay. Trace means here sum of the diagonal elements. Let A is equal to Aij. The trace of the square matrix A is defined as sigma I is equal to 1 to n A I, and it is denoted by trace of A. Okay, here, what about the trace A, B, C? Then trace of A is equal to A plus B plus A. Sum of the diagonal elements is equal to the trace of A. Okay, and the properties of that, trace of lambda into A is equal to lambda into trace of A. Trace of A plus B is equal to trace of A plus trace of B. And trace of A into B is equal to trace of B into A. And similarly, idempotent matrix. If A is a square matrix such that A square is equal to A, then A is called as idempotent matrix. Okay, A square is equal to A. Nilpotent matrix. If A is a matrix such that A power m is equal to 0, where what is m? M is one positive integer, then A is called nilpotent matrix. If A is a square matrix such that A power m is equal to 0. Idempotent means A square is equal to A. And involuntary matrix. If A is a square matrix such that A square is equal to I, then A is called involuntary matrix. If A square is equal to one identity matrix is called as involuntary matrix. Nilpotent means A power m is 0. M is any positive after multiplying with power of A power m is equal to 0 means that is nilpotent. A square is equal to A means that is idempotent matrix. Next, orthogonal matrix. A square matrix A is said to be orthogonal if A into A transpose is equal to A transpose into A is equal to I. Okay, A into A transpose or A transpose into I is equal to I is called as orthogonal matrix. Okay, one example, show that A is equal to cos theta sin theta minus sin theta cos theta is orthogonal. Okay, for that this is A and this is A transpose. Once observe how we are finding that A transpose cos theta and the transpose. That means some rows and columns are interchanged. That means here the cos sin theta. Here row will be interchanged to column. That means here row will be interchanged to column. That means A into A transpose is equal to cos theta sin theta minus sin theta cos theta into cos theta minus sin theta cos theta. Multiply the two, that is row with the column. That is, their two are cancelled and these two are cancelled. That means here A into A transpose is equal to what? I. Or again A transpose into A is also equal to I. This is orthogonal matrix. Next, similarly, inverse of a matrix. Let A be any square matrix, then a matrix B, if exists such that AB is equal to BA, then B is called inverse of A and it is denoted by A inverse. AB is equal to BA is equal to I. From that, B is equal to A inverse. From that, A inverse whole inverse is equal to A. And I inverse is equal to I. Okay, important points for the inverse. A inverse whole inverse is equal to A and I inverse is equal to I. And adjoint of a matrix. Let A be a square matrix of order n. The transpose of the matrix got from A by replacing the elements of A by the corresponding cofactor is called the adjoint of A and it is denoted by adjoint of A. For any scalar k, adjoint of k is equal to k power n minus 1 into adjoint of a. The necessary and sufficient condition for a square matrix to possess inverse is that det A not equal to 0. If det A not equal to 0, then A inverse is equal to what? 1 by det A into adjoint of A. Singular and non-singular matrices. A square matrix A is said to be singular if det A is equal to 0. That means a square matrix A is said to be singular if det A is equal to 0. If determinant of A is equal to 0, then that matrix is called as singular. Second point, if det A not equal to 0, then A is said to be non-singular. Okay, here important points. That means when that inverse exists either with a singular or non-singular for that non-singular matrix. If det A not equal to 0, for that case only inverse exists. Only important points, only non-singular matrices possesses inverse. Inverses. Only non-singular matrices possesses inverse. Second point, the product of non-singular matrices is also a non-singular. The product of non-singular matrices is also a non-singular matrices. Okay, these are the definitions for the first unit. We discussed all and we discussed all type of questions in the previous classes. Okay, go through that. Okay, this is the concept, each and every basic concept in the module 1. Okay, thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.